Alright, folks. Today we're going to graph advanced tangent, is what I'm calling it. It's basically a tangent graph, but with something else inside. Whoops. But here's the thing. It's still in the family of tangent, and tangent is always sine over cosine. Okay? So, what does that mean? It's still going to be related to cosine. And as a result, since it's a fraction with cosine on the bottom, it's going to be, let's put a theta in here for reference. It's going to have asymptotes when cosine is 0. Not when the angle is 0, but when this whole thing equals 0. Okay? It's just like when we graph things like 1 over x minus 3. There's asymptotes if the bottom equals 0. Not when x is 0, but when the whole thing equals 0. So this is in the same family. Okay, so when does cosine equal 0? Well, you can do that with a unit circle, or if you know the cosine graph, you know it goes like that. Roughly. It starts at 0, ends at 2 pi. And it would finish another cycle by 4 pi. Alright. Now, what we're concerned with are the zeros. Those are all these points. Okay, so again, if you remember the cosine graph, 0 to 2 pi. So the middle is pi, and this is pi over 2. 3 pi over 2. Let's focus on just these ones right now. Okay, so pi over 2 and 3 pi over 2. Alright. The other thing you'll notice is 1 half, 3 halves. The next one will be at 5 halves, then at 7 halves. And the whole point is, once you know that, this method works for however many cycles you want to do. Okay, so what we're focusing on there. Used to have an asymptote at pi over 2, or sorry, used to have a 0 at pi over 2. Let's set that equal to pi over 2, and that will give us our new location. Same thing with over here. If we set it equal to 3 pi over 2, we'll have our new location. Okay, so let's solve this. So this is just like having 2x minus 3 equals 1 half. It's exactly the same thing. Instead of 3, it's 3.14. It's pi. Okay, so 2x here, the pi's cancel. 1 half plus a 1. This is 1 half pi plus pi. That's 2.5 pi. Sorry, 1.5 pi, or 3 halves pi. Or basically, let's do this. Pi over 2. Pi is 2 pi over 2, because 2 over 2 is 1. So what we get is 3 pi over 2. Whoops. Slide it up so you can see it here. Okay. Well, how the hell do we solve that? Well, usually we divide by 2, but we already have a fraction over here. Well, division is the same as multiplication times the reciprocal. And 1 half times 2, when we multiply this, we get 2 over 2x equals 3 pi over 2 times 2 is 4. So x equals 3 pi over, 3 pi over 4. Alrighty. So that's one of our asymptotes. Our other asymptote, let's solve this. Plus pi, same thing. 2x. Again, this is 3 halves pi. Pi is 2 halves, because 2 over 2 is 1. So that gives us 5 halves pi. 3 halves plus pi, so there we go. Alright, 2x equals 5 pi over 2. Multiply by the reciprocal, multiply by the reciprocal, and these will cancel. You'll just have x equals 5 pi over 4. Okay, so take a look at that. The reason we did 2 of them is this will help us find the period. Okay, it's not obvious, but we can tell how it's changing. Okay, looking at the original equation, it's hard to tell what the period is, but from here we can say, oh, it goes from 3/4 to 5/4. If it follows that pattern, the next one will probably be at 7/4. If we went backwards, the other one would probably be at 1/4. So 1/4, 3/4, 5/4, 7/4. 1/4, 3/4, 5/4, 7/4. And we can verify that's true, but if you have a common denominator like 444, then just look for the change in the numerator, and that's how it's counting. All right. So those are our key locations. Let's start with those. Let's move this over. We're almost done here. 3/4 was one of our cycles. Sorry, one of our asymptotes. 5/4 was one of our asymptotes. I like to do them in highlighter because the asymptote is not really there. It's an undefined location. It's like a brick wall you're not going to cross. You can't go through it. What's going to happen is your tangent will get closer and closer to positive infinity or closer and closer to negative infinity. And right in the middle of 3/4 and 5/4 would be 4/4 or just 1 pi. Alrighty? And that's the thing. Tangent's totally repetitive. So after you know this, the next section just looks like this again and again and again. So if you copy and paste, copy and paste, copy and paste, it's just repetitive. The other thing that's nice is if this is pi, this is 5/4, the next one will be at, the next one's not going to be 2 pi though, don't make that assumption. But 3/4 to 5/4, 5/4 to 7/4. And what's in the middle of 5 and 7? Is 6, so 6/4, or that's 3/2. All right. But again, as you go up, it'll shoot towards its asymptote. As you go this way, it'll shoot down towards that. And it'll just keep on doing that all day long. All right. All day long. So, the point here is this. It doesn't matter what they give you inside tangent. They could give you 3.5x minus 2.9. I won't give you that. I'll give you something a little bit whole numbery, or at least with pies and stuff. But the whole point is it doesn't matter. Set this equal to where your old asymptotes used to be, and that will help you find your new asymptotes. All right. Hopefully that helps, and bring lots of questions tomorrow. And, oh, yeah, that's about it. I was going to say one last thing. Never mind. All right. Thanks for watching.